The title was originally deep dive because I only have 25 minutes, so it's just a regular dive, so not that deep. So my previous record for this talk has been 29 minutes and 38 seconds, so let's see how can we do today. So there's a lot of things I'm going to cover today, so just jump into the subject. But before we go forward, this is a tweet about a year ago from my friend. So he has a kind of policy for social media. So whenever he's sharing his slides, he's getting the worst picture of him. So whenever they see him live, they are like, hey, that's not that bad, and this is how he looks like. So, my name is Dr. Nestori Syynimaa, also known as Dr. Adversary-in ID, and I work for Microsoft. I need to double check what the organization is nowadays because I was reorged on Monday, so it's Cloud Application Identity Research. And what I do is, so I kind of two things. So one is that I'm trying to find vulnerabilities before the bad guys do, so you're welcome. And the second one is that I'm trying to educate people, and that's part of the role I'm here today. And I created a tool called AID internal. Some of you might know that. I have some stickers which you can get after the talk if you want to. And if there's no time for questions, I will stay here, hang around after the two other talks, so we can have a chat if we want to. And this is almost the last speak or talk in my the non-US tour 2025. And last time I checked, Canada is not part of the US, so happy to be here. And I only have one thing left, unless I got accepted to other things. So I just need to go to Buenos Aires in 3 weeks. So it's going to be 3 different continents tour. Okay, so let's start then. So with token-based authentication attacks. So let's start with the key concepts that are involved in when we are talking about token-based authentication attacks. So we have 3 roles. So first is user, who is consuming services. The second role is service provider, who is providing services. And lastly, we have identity provider, who is providing identity and access management services. Examples could be like me as a user. Then we have a service provider, let's say Exchange Online. And then we have the identity provider, Entra ID in this case. So how cloud works in one slide, so we can put these roles into actions. So first, there's a user like me, Nestori. I want to access Exchange Online using Outlook. So I need to first start and go to identity provider, or Entra in this case. And Entra doesn't know anything about me. So it only knows about me what I tell it. So I need to prove my identity. I can use username and password. I could use FIDO keys or whatever. But anyways, I prove my identity to Entra somehow. And when Entra is happy, Entra believes who I am, it creates an access token, a refresh token, and then sends those back to the user. And then I can access the actual service. I go to service, but again, the service provider doesn't know anything about me, except what's inside the token. So now I already logged in. That access token says, okay, this guy is Nestori. He can access Exchange Online using Outlook for 1 hour. And after that expires, you need to get a new token. But that's kind of how cloud works. And then start with a couple of quotes. So first is that attackers doesn't break in anymore, they just log in. So quite easy, because there's nothing where to break into anymore. And then let's see some statistics. So this is from our report called Microsoft Digital Defense Report 2024. And what we have witnessed is that most of the attacks are nowadays password attacks. It doesn't mean that they are successful, but they have been trying to attack those. And only 1% is something else, like what we have here. Oh. Wrong way. And let's try this. So we have, for instance, token theft. And why that is important is that nowadays, well, who is using MFA to log in? Okay, who is using FIDO keys or something like that? Yeah, so it doesn't matter if somebody steals your password. They don't have any use with those. So that's why they are stealing tokens, and that's why we are focusing on that. Okay, second quote from our security vice president, John Lambert, which is a quite famous quote. He said that every time he would have a dime when somebody's showing this. So basically, what thing is here is that that attackers, they try to find any way to the end goal, whatever that is, and we need to be aware of those. So it doesn't work like it used to be, that I have a firewall and that's it, because there are other ways to get into. So that's why I'm using graphs. Now, my name is Dr. Azuredi, or Handels, because I really am a doctor, so I'm doing like this, like proper research also. This is a paper I sent to a conference, and when you kind of like send these kind of papers, and this was about graph theory and attack graphs, so they are reviewed, right? And the first review was, yes, this is very good. Second one wasn't that nice to me, if you will. So his or her first question was, so where is the graphs and where is the graph theory? And that wasn't the first question. So it looks like this. So I made nice graphs, but it didn't work. But anyway, it was accepted. So my interpretation about graphs, I think that's okay. So that's why we are having these graphs now. Yes, so this is like the whole token-based authentication attack graph. So you have two options. So if you are a nation-state actor, you could steal secrets, let's say from us, that you can then use to forge tokens. And that actually happened a couple of years ago. So there was an actor from a country who was able to get off the hands on one of our signing keys. And if you're not like a nation-state actor, sorry about that, then only thing that you can do is to steal tokens. But I had to update this graph 2 weeks ago, because there's a guy called Dirk-Jan Mollema, who was one of my friends, so he found a way that he could just forge tokens to all the tenants in the whole wide world. But that's now fixed, but still this is quite accurate. So let's just jump over of these and then to token theft. So they are kind of like, we have witnessed like two kind of things. So first is like what we call sometimes network-based attacks. And that involves kind of a link to some site which looks like our site, but it's not. And then there's Adversary-in-the-Middle who is collecting our stuff. And so basically, you are not going to our login page, but you are directed to some bad guy. And you can use whatever thing to implement this, but evil thing is quite often used. Who has heard about this? Okay. So I'm going to show a demo about that. So let's hope that demo cards work, because I had this presentation like 2 weeks ago in Belgium, and the network just didn't work, so no demos. Okay, evil things, and we start that in developer mode. And I'm gonna copy the URL, and as you can see, this is like the URL. So just one letter replaced with a 0. And we can copy this. And then we go to the victim's computer here. And our victim is using Chrome. And now he's clicking link. Okay. And now this looks like our sign-in page. But again, when we go up here, we can see that it's not. Okay, so username. And then password. Of course, I'm not using my real password because I saw that last weekend in Rome, so I had to change that. But anyways, you can see that here it says that hello Toronto. And now I'm going to move this away. But basically what happens here that whenever now you enter your username and password in that kind of site, even that you are using MFA, they can get your username and password, and you might use that in other places, so that's one value. And the second one is that you will get hand to session cookies, which then you can use later on to log in as that person. So that was one of the attacks. And the second one is that if you are, sorry, where it is? Okay, let's hope this works. Okay, and the second attack is that if you have access to user endpoint, then you can steal stuff from there. And there are sort of things that you can steal. So first one is that if you are like a local admin and there's no TPM, you can steal the identity of the device. So keys that can be used to like prove the identity of the device. And if you have no admin permissions, you can still steal a lot of stuff like session cookies and certain keys and tokens and so on. Sorry, not keys, but cookies and tokens. And what kind of tokens you can have? So there's also a lot of different like tokens. Others are more valuable than others. And the first one is like what is called primary reference token, or PRT, and a session key that is like bound to that token. So again, if you are a local admin, you know users' username and password or PIN, and there's no TPM, you can steal that. I'll demonstrate that later. And then we have like different kind of tokens. So, but there's a little time, so we are not going to go deep dive into all. But the PRD is like the most valuable because it gives you persistent access to any resource using any client. The normal reference token gives you a persistent access to one resource and one client. And then the access token gives you access to a certain client, certain resource for a certain period of time, which is anything from 1 hour to 28 hours. So it depends which kind of configuration you have. But we will get back to those later. And a demo for that. So let's start with user permissions. So easiest way is to start the best browser in the world called Microsoft Edge and hit the hacker button or F12. So now it starts kind of recording that what is happening here. And what do we want to search from here is like a string like this. So whenever you are authenticating, you are using like services, like with Outlook, you are calling a certain API, and there's a header called authorization, and it has the bearer, and then there's your access token. So let's start, just search for those. And there's a lot of them. So let's take the first one. So basically, you just copy this. So now you don't even need to log in because you are the person, if you just copy and use this. I'm just going to show you what's the content. So data.wt.ms. I paste it there. And then when I move down, we can see that you have a Outlook web, and you can access Graph. And Graph API is like our API that you can pretty much do anything. And we have some scopes here also somewhere here. So you can do these things if you have like permissions in the backend. But anyways, quite easy, nothing to hack. And the second one is that we are now compromised the endpoint. We are administrators. So we can then just import my toolkit called AID internals and for the endpoints version. Endpoints, hit the enter. And it doesn't work because this was blocked by your antivirus software. So let's just remove that and And we can do this because we are the hackers. Okay, let's try again. Much better. Okay. I should have the credentials already here, yes, so I can just say get AID into user PRT keys from the cloud access AP cache. I provide the credentials. And now because there's no TPM this machine, I can do this. So now we have the refresh token or PRT and also the session key that is required to use that. So I need to speed up a little bit, but anyways, now we have the attack token theft attack graph. So basically, can you access endpoint? Yes. If you have no permissions, you can just steal tokens. If you have permissions, you can install malware and steal tokens, or you can even steal secrets in some cases, and then you can acquire tokens. So let's imagine that you have the PRT and session key, then you can ask for new tokens and then just use them. If you don't have access, then you can use Adversary-in-the-Middle and to steal tokens. Okay, so we have a kind of the three token security best practices. First is conditional access policies. Who have heard about those? Okay. And then we have a token binding. And then we have continuous access evaluation. So let's walk through of these three things. So how these conditional access policies work. So basically you go to Entra and you say that who you are and so on, and they are evaluated there. So basically you can limit that, okay, I can't access Exchange Online, or I need to use MFA. But anyways, if Entra is happy, you will get access tokens and then you can access the service. So conditional access policies may prevent against adversary-in-the-middle attacks and also to acquire tokens. And how? So for instance, you can require that you can only log in from the devices that are like compliant, and the adversary-in-the-middle guy is using computer that is not that compliant, so you can block that. And the acquire tokens means that you can configure that. Okay, you can't log in unless you are in the safe network or that kind of thing. So you can use that to prevent that. So a quick demo about that. So I have a tenant here. I go to security, conditional access, check the policies, and require compliant device. And I just turn it on. And that should do it. So now, so let's try the Chrome. Okay, now I'm going to use the real password. Okay, but it says that you can't get there from here because I use this simple rule that requires that I need to have like compliant device. Okay, then to token protection. So I'll just like walk this through quite quickly so that we can get to the point here. So how this works is that you have a supported device. You go to Entra and you say that I'm using, this client is supporting token protection. So give me protected token. And what then happens is that Entra sends you access token, but those are encrypted using the keys that are available on the endpoint. Okay? And then when the tokens come to the endpoint, they are decrypted and then after that they are used. So token protection protects tokens in transit, but whenever they are reaching the endpoint, you can still get those decrypted access tokens. So it prevents adversary-in-the-middle attacks, because even though that you are able to intercept those tokens, you don't do anything with them because they are encrypted. So that's what this thing does. And the last part is what we call continuous access evaluation, or CAE. I don't know how to pronounce that. So how that works. You go again to Entra, and Entra doesn't know that does your client support that, so you need to tell Entra that. So you said that, okay, I support, this client supports this type of token. And Entra will send you a token, but that token is now valid for up to 28 hours. So not 1 hour, but for 28 hours. And why is that? So let's see. So you can consume a service with that access token now, but this continuous access evaluation means that Exchange Online, for instance, it supports that. So Entra is sending like critical events. Like for instance, if user's password is reset, it can say that you need to re-authenticate. But if you have the normal access token that is valid for an hour, so even though you reset user's password during that hour, you can still use that. But with this, you can't. So that's kind of like what it helps us to do. So this conditional access evaluation may prevent token replay. So if you get it from this endpoint, for instance, you can configure that you can only come from the same IP that it was originally requested. And may, because not all clients supports that, so it's not like a silver bullet. Now, this is an interesting part that threat actors can exploit this. So to use this, you need to have like P1, Premium 1 license, but you can use this even though that you don't have that. So threat actors can, for instance, if they are able to compromise your endpoint, they can go and ask and say that give me CAE compatible like access token, which is valid for 28 hours instead of the 1 hour that it used to be earlier. So here's like a short KQL you can use in your log analytics to search for that activity. But we will get, you can have those slides after the talk. So let's just move to the last slide, which kind of summarizes everything. So we have these things, so like conditional access policies and token protection, that helps to prevent adversary-in-the-middle attacks. Then conditional access policies can help us to protect against this one. And conditional access evaluation, the last part, helps us to protect this one. But there's no mitigation for this part. So if threat actor is able to compromise your endpoint, depending, do they have like local admin access or not, they can steal tokens or they can still install malware and then steal tokens. And the only AI-related stuff in my slide deck is next one. So I ask AI to create a Simpsons-themed old guy with a ponytail shouting at the cloud. So with that, thank you.